sklearn, discriminant analysis, quadratic discriminant analysis. Description: a classifier with a quadratic decision boundary, generated by fitting class conditional densities to the data and using Bayes' rule. The model assumes that the data within each class has a Gaussian distribution and uses the mean and covariance matrix of the data to determine the decision boundary. Inputs: X the training input samples. As a 2D array, each row represents a sample, and each column represents a feature. Y the target values class labels for the training samples. This should be a 1D array of integers or strings. Outputs: self the fitted quadratic discriminant analysis object. This can be used to make predictions on new data. YPRED the predicted class labels for new input samples. This is a 1D array of integers or strings, with the same shape as the input data. Steps: initialization: initialize the model with specified parameters. Training: the model learns the mean and covariance matrix for each class in the training data. Prediction: given a new input sample, the model calculates the probability of the sample belonging to each class based on the learned class parameters. The class with the highest probability is assigned as the predicted class. Metrics: accuracy: the proportion of correctly classified samples. Precision: the proportion of correctly classified samples among those predicted to belong to a specific class. Recall: the proportion of correctly classified samples among those that actually belong to a specific class. F1 score: the harmonic mean of precision and recall. ROC AUC: the area under the receiver operating characteristic curve, which measures the model's ability to distinguish between different classes. Visualization plots: decision boundary: a plot that shows the decision boundary separating the different classes. This can help to visualize the model's predictions. Scatter plots: scatter plots can be used to visualize the distribution of the data within each class and to identify outliers. Fine-tune parameters: priors: the prior probabilities of the classes. If not specified, the priors are calculated from the training data. Regparam: a regularization parameter that adds a small value to the diagonal of the covariance matrix to prevent numerical instability. This parameter can be adjusted to improve the model's performance. Uncertainty methods: probability estimates: the model provides probabilities for each class for a given input sample. The uncertainty can be measured by the difference between the highest and second highest probability. Challenges and fixes: challenge 1: the model may overfit the training data, resulting in poor performance on unseen data. Sample use case: a model trained on a small dataset of images may classify images from a different dataset with low accuracy. Fixes: regularization: use a larger regularization parameter to prevent overfitting. Cross-validation: split the training data into multiple folds and train and evaluate the model on different combinations of folds. Challenge 2: the model can be sensitive to outliers in the data, which can affect the learned class parameters and the decision boundary. Sample use case: a single outlier in the data may significantly shift the decision boundary, leading to inaccurate predictions. Fixes: data preprocessing: remove or adjust outliers in the data before training the model. Robust estimation: use robust methods for estimating the mean and covariance matrix, which are less sensitive to outliers.